Whoop. Well, here we go. There we go. Hi, and welcome to Climate Chat. I'm your host, Dan Miller, with my co host, Leon Simons, over in the Netherlands. Welcome, Leon.
Hi.
And today we're going to be talking about the unintended consequences of reducing fossil fuel emissions. As we all know, we have to reduce our fossil fuel emissions, but we need to understand what that means if we focus solely on that, for example, and what are the near-term consequences of doing that. Before we get started on that, I want to tell you about some upcoming guests we have. The next Sunday, July 13th, we have Sanjay Waggle, who's an investor who focuses on adaptation opportunities. Some adaptation's not something we've talked a lot about on Climate Chat, although our last show included some of that for farmers, adaptation for farmers. But anyway, so we'll be talking with him about that. It'll be really interesting. And then at a special day, Thursday, July 17th, we have Matthew England as a returning guest. He was a guest on our Clubhouse version of Climate Chat, but not on the YouTube. And he has an alternative explanation for the recent acceleration in warming having to do with ocean stratification. So that will be really interesting. He's also done research on AMOC collapse. That's what we talked with him about last time. There's some new research on Southern Ocean circulation. That's an area he studies as well. He's based in Australia. So that one actually is at a different time. I don't have written down right here. And then the following Sunday, we have Ben Santer. Ben is a well-known climate scientist who's semi-retired now. And his work focused on how we know that humans are causing climate change, the human fingerprint on climate change. And we'll be talking about that. And then on Thursday, July 31st, also, but at 10 o'clock, at 10 a.m. Pacific time, Stephen Chu, former Energy Secretary, Nobel Prize winner in physics, and currently a professor at Stanford, doing lots of interesting research. And we'll be talking to him about climate change and also the politics of climate change, since he was in the Obama administration. So we'll have a chance to talk to him about all of that. And so you don't miss any of this, please like and subscribe. When you like a video, it's shown to more people. And this is an important subject we need to get across to more people, so you can do your part. Also, then if you like and you hit the bell notification, you'll find out about these programs, which are not always at our standard Sunday at 10 a.m. time. So that's a little upcoming on Climate Chat. So let's get into this discussion. I think it's going to be a little bit controversial, because when you look at what the mainstream discussion of climate scientists are, or climate activists, you often hear we have to focus on reducing our fossil fuel emissions. And therefore, anything else that you try to do that interferes, that could theoretically interfere with that, take our hand off the ball there. When it comes to reducing fossil fuel emissions is bad. And so that's the only thing we should do now. Yeah, maybe once we've really gotten that under control, then we can go off and look at things like carbon removal or solar radiation management or things like that. But doing any of those things now would decrease the impetus to do carbon removal, and that would be bad. So we're going to talk about that and how that actually could be a moral hazard because of the consequences of going down the path of, and I'll use the phrase, emissions reduction only. Doesn't mean you don't do carbon removal way in the future, but focusing right now only on reducing emissions, as opposed to emissions reduction along with other things, which is a whole different discussion. Well, we'll talk about that as well. So one of the first impacts we'll see as we reduce our fossil fuel emissions is the temperature will go up depending on which fossil fuel emissions you're reducing. And we're already seeing this because while we didn't really reduce the CO2 emissions from shipping, we did reduce the sulfur emissions from shipping through new International Maritime Organization rules that came into effect in 2020. And then we saw global temperatures accelerate starting in 2023. And you might ask, well, why didn't it accelerate in 2020? Well, there was a La Nina in 2020, let's see, I'm gonna get this one, 2021, 2022. And that countered the warming from the shipping emissions rule change. Once the El Nino kicked in, it was no longer canceling, it was adding to it, and we saw a huge jump in temperatures. That same rule, a similar rule kicked into effect May 1st of this year in the Mediterranean, and right now the Mediterranean temperatures of the Mediterranean Sea are skyrocketing right now, and people are wondering why. So we have with us Leon Simons, who's probably the world's expert on this particular issue. So I'm going to just turn it over to Leon to tell us about why reducing fossil fuel emissions and certainly the aerosols that are associated with those emissions, why getting rid of those, which there's good reasons to get rid of those, but they also have consequences. So over to you, Leon. Oh, I'm not hearing you. I think you're muted.
Thank you, Dan. Hi. Yes, and we call these the unintended consequences because, of course, the intention is not to cause more warming. The intention is to reduce health impacts, to reduce environmental impacts, and of course, reducing fossil fuel emissions. The intention is also to reduce the greenhouse gas concentration and to reduce initially the rate of warming, and then to reduce warming altogether, and hopefully even cause some cooling eventually. But we are talking about the unintended consequences, and there's quite a lot of those indeed. And let me share my presentation here. Yeah, so what we see here, and I think it's always important to start with this to show the greenhouse gas concentration for what it is today, and here comparing it to the past 130,000 years. And so at the start of the Industrial Revolution in 1750, CO2 concentration was about 280 parts per million. And if you take into account all the other greenhouse gases in the atmosphere, both before the Industrial Revolution and to today, you see that the current greenhouse gas concentration is about 573 parts per million CO2 equivalent, and then that's equal to a forcing of over 4 watts per square meter over the entire Earth's surface, which has 510 trillion square meters, and that's so that is higher than the 560 parts per million of CO2. So we're already at the doubling of CO2. If you, I think my camera stopped. Let me make it smaller. So we're already at a doubling of CO2 if you take the other greenhouse gases into account. And then there's, of course, you can also look at it from a heat perspective. And then we are now adding about 1 billion Hiroshima bombs per year to the Earth system as heat. And that's also really an enormous quantity, of course, of heat added to the Earth system. And part of that is taken out because there's an increase in outgoing long-wave radiation as the Earth heats up. But what we see now is that there's still a lot more heat added to the system because of this greenhouse gas forcing.
So that's like an eighth of a Hiroshima bomb for every person per year for every person on the planet.
Yeah, so there's about
everybody's responsible. Well, that's not really true that everyone's responsible. Some people are responsible for a lot more, and some people are responsible for a lot less. But on average, 1/8 of a Hiroshima bomb per person per year of heat added to the Earth system.
Yeah, exactly. Wow. So that's a lot of heat. we discussed it before that it's really, I think no one really can grasp how enormous these numbers are. There's really a lot of heat added to the Earth system by these greenhouse gases, or kept inside the system, because of course the sun brings this heat to Earth, it radiates heat to Earth, and the greenhouse gases keep more heat inside the Earth system than would be kept inside without these greenhouse gases, right? So also, if you see that some say that it's because the absorbed solar radiation is increasing, so more sunlight is being absorbed, that's causing the warming. But you have to take into account the added greenhouse gas, otherwise this additional heat would rapidly be radiated back to space. You can see that, for example, in the desert, where there's very little water vapor, which is also a strong greenhouse gas. Then the nights cool down by 30 or sometimes even 40 or 50 degrees Celsius. So you can have freezing temperatures at night and really enormous, very high temperatures during the day. So that's one indication of the strength of and the importance of the greenhouse gas effect. So, but then let's get to of course, in a way, this is also an unintended consequence of burning all this fossil fuel, right? But now let's get to the unintended consequences of reducing emissions. So I think now. Yeah, so what you see here is the main drivers of global warming, and these are the biggest two, are of course greenhouse gases, well-mixed greenhouse gases, and if you add some more greenhouse, if you also add tropospheric ozone, for example, this will be even higher. So, and that's around 2014. So around 2014, we would already be at 1.5 degrees or above 1.5 degrees Celsius of global warming, without especially sulfur dioxide emissions. So without the burning of sulfur, we would already have reached most likely the 1.5 degrees of global warming.
Well, 2.
Sorry?
Without sulfur right now, we would be at 2 degrees of warming. Is that what you meant?
Yeah, so this is according to the IPCC. We would, in 2014, already be about 1.5 degrees Celsius.
Oh, I see, from back then. But right now we're, as we've done on this program many times, we're about at 1.5 degrees now because of recent acceleration. And if you add the 0.5 degree down there of the sulfur, then you add half a degree to 1.5, you're at 2.
Yeah, more or less. Yeah, and then there's this big uncertainty.
Right.
But our research and more recent research shows that the cooling effect of sulfur is likely much stronger than most thought, and that also means that the IPCC estimate is likely an underestimate of the cooling impact, and therefore an underestimate also of the greenhouse gas warming impact, because this uncertainty for the greenhouse gas warming, that's mainly caused by the aerosol uncertainty.
Right.
It's a response from the total greenhouse gas forcing.
Right. And let's say that again, because I think it's really important point. So on this graph, which was from when it was earlier time when we said the overall warming was 1.1 degrees when this graph was made. So now we say it's 1.5. Let's keep it at 1.1. With what Leon just said, if the cooling from sulfur dioxide is, let's say, 1 degree instead of 0.5 degree, that means the actual warming from let's say it's 1 degree, 0.9 degrees. So keep it simple like that. If it's 0.9 degrees, that means that the warming from the greenhouse gases right now is 2 degrees. Actually, it's even more now, but 2 degrees with minus 0.9 from the aerosols, which give you the 1.1. So another way, a simple way of putting it, if the cooling turns out to be more than the IPCC thinks, that means the cooling from aerosols is more than they think. That also means that the warming from greenhouse gases is more than they think. And therefore, when we get rid of our fossil fuel emissions and get rid of the aerosols, we're going to see more of a temperature rise than was expected.
Yeah, Yeah, in simple terms, it means that the climate is more sensitive to whichever direction we force it in. Whether with greenhouse gas, we force it to be warmer, right? We call it forcing agents, but so we push it into a warmer state by adding all these greenhouse gases. And if the climate is more sensitive, that means that the push from greenhouse gases into the warmer direction is stronger. And the push back from aerosols is also stronger if the climate is more sensitive to what we do. So and I think that's quite important, because often you hear that it's when people talk about climate sensitivity. So when they say, for example, no, it's not aerosols, it's climate sensitivity, but in a way they say the same thing, right? Because it just means the climate sensitivity is higher. So that means, and of course, then you could talk about feedbacks or forcings, and it can get quite complicated for most people to understand quickly. But it's if you just look at these basics: greenhouse gases, sulfur, and climate sensitivity, then I don't think it's very complex, right? So and then I think it's good to look at this second graph. So this figure here and this map, where you see in 2010 the sulfur emissions over the different over the different regions, where you see that, and there's a logarithmic scale, because also the impact of these aerosols is non-linear. So a low emissions has a strong impact, especially if there's not so much local aerosols available, so local and not a lot of sulfur locally available. So that's why you see that over the oceans, of course, that was the shipping in 2010. But also India, China, Europe, many parts of the US, especially, of course, where most of the industry is based, and yeah, mainly where people live, of course, or at least where there's some industry. You see that there's quite a lot of sulfur being emitted, and that's caused by the burning of fossil fuels. And in 1991, James Hansen published a paper where they said, if we would reduce the fossil fuel burning, so introduce more cleaner alternative energy sources like solar, wind, hydro, nuclear power, which don't emit or almost don't emit CO2 or methane, you would also stop emitting most of this particulate air pollution, which has been reducing the warming. And then that's what he called it, a Faustian bargain, where you are faced with the harm that was associated with all the benefits from these fossil fuel use, right? And of course, the benefits are clear to, I think, everyone who uses energy. It keeps our lights on. It gives us water from our taps. It brings us to places. It heats our homes. It provides power for our air conditioning. So of course we are well aware of all the benefits the fossil fuels bring. But now we've been kept quite blind over the past 100 years over the warming impacts. And now that we're starting rapidly reducing these sulfur emissions, now we're being faced with the unintended consequences of both reducing these reducing sulfur particles and reducing the dimming, and then also of course the initial unintended consequence of all these added greenhouse gas to the atmosphere.
Now there is another quote unintended, well, and hopefully intended consequence of reducing, for example, even though aerosols go, when aerosols go down, as you reduce fossil fuels, warming goes up. But one of the greenhouse gases we would reduce is methane, or fossil gas, sometimes called natural gas. And when that happens, it has a lifetime of 10 to 20 years. And so when that fades out, that component of the red line there of the well-mixed gases, methane is isn't it like 2/3 of what CO2 is or something in terms of warming? Um,
Yeah, it's a bit less, but it depends also how you count it, because you indeed on the shorter time frame, if you add it, if you emit it, the warming impact is much stronger, over 80 times in, I think, in the 20
oh,
25 years. It's 80 times stronger than CO2. But if you look at what's in the atmosphere, I think it's about
120.
half.
I mean, in the
Yeah,
atmosphere, while it's in the atmosphere, again, it doesn't last nearly as long as CO2, of course. CO2 lasts for hundreds to thousands of years, and some of it remains for like 500,000 years. But methane lasts for 10 to 20 years. But while it's in the atmosphere, during that time, it's 120 times as powerful as CO2. When averaged over 20 years, when a lot of it goes away during that time, it's about 86 times. And if you average it over 100 years, when almost all of it goes away eventually, it's like 30 something times. But the 120 times is what I'm talking about. Is so if we get rid of that component of warming, that would that cooling from getting rid of methane would partially offset the warming we get from getting rid of aerosols. Now, the aerosols react much faster. They drop out of the atmosphere in about a week, right? So if we turn those off, you get the warming impulse right away. And if you're countering methane, which we're not doing, by the way, right now we're just lowering aerosols and increasing methane. So
yeah,
we're
very
doing
rapidly.
it totally the wrong way. But if we did do it the quote right way, we would still get that warming pulse, and then maybe over 20 years it would be offset by the elimination of methane. But any further thoughts on that? Or
Yeah, and you also have to take into account the effects of, for example, ozone, tropospheric ozone, which strengthens the methane forcing. So the methane forcing is stronger than just what the methane forcing is, in a way, if you take all the impacts into account. And then, of course, it's we are in a way also now doing the opposite by increasing methane.
right.
Through increasing fracking, and
LNG, liquid natural gas,
LNG,
shipping around the world.
exactly, shipping it around the world, and liquefying it, and then or what do you call it, deliquefying it, or regasifying
Right.
the liquefied methane, and in this whole chain, so from well to stove, or to burner, you see, of course, that there's a lot of also methane being going into the atmosphere, and that if you do the math, and it depends where this methane, of course, comes from, but often the methane emission, the effect of this methane, especially in the first 20 years, makes it on the short term worse than coal.
Right.
So the first decade, and that really adds to the rate of warming. So of course, there's many ways we can reduce methane emissions, not just by reducing the leaks, but also by reducing agricultural emissions. Did I freeze? Yeah.
Yeah, your screen froze there for a moment.
Yeah.
Maybe
I don't know.
there we go.
Yeah.
By the way,
that's-
speaking of that, I mean, this is a pretty important point, is that countries around the world are trying to show they're meeting their Paris Accord targets and things like that. And one of the ways they do that is by switching from coal electricity generation to natural gas electricity generation, and or methane, basically. And methane, natural gas methane, has roughly half the CO2 emissions per kilowatt hour generated in the power plant. And that's
Yeah.
true. It is, roughly half. And so these countries take credit for reducing CO2, reducing their greenhouse gas emissions by switching from coal to natural gas. However, when you really look at it, even a tiny bit of what's called fugitive emissions or leaks of methane that escape before it gets burned in the power plant, or after it was burned if it leaks as well. It's 120 times more powerful than CO2. So even the tiniest of fugitive emissions overwhelms the benefit of this lower CO2. Plus, and this is a real important point we should go more into, natural gas doesn't have the aerosol emissions that coal does. So the bottom line is that switching from coal to natural gas, while you get to on your accounting sheet, say you've reduced your CO2 emissions, in reality increases global warming, like almost immediately as soon as you do it. Eventually that CO2 benefit will overtake, but I understand it's about 100 years before you get a benefit of reduced warming due to that switch. So the bottom line is you shouldn't switch from coal to natural gas. First of all, that will immediately increase global warming, but you should switch from coal and natural gas to renewables. But one of them, speaking of the unintended consequences, has far less unintended consequences, and that is reducing methane emissions, because methane doesn't come along with the aerosols, number one, and as we also just spoke about, has very high warming that goes away quickly if you get rid of it.
And that's not accounted for either, right? That's at least not in the balance sheet. Of course, if you look at the balance sheet of a coal-fired power plant, it doesn't. When it's installing these desulfurization systems, they don't get fined for the warming impacts of that, right? So they get the benefits for example, you get benefits when you don't emit air pollution because you improve health, or you get fined when you do emit them, right? So there's an incentive to reduce sulfur emissions, and that's of course from an environmental and health perspective that makes a lot of sense. But as we discussed before with Vince Gauci, that also increases, if you reduce sulfur deposition of wetlands, that also increases methane emissions. So there's many things to consider.
That's right. And by the way, you mentioned it briefly there, but it's worth emphasizing that there is a really good reason to get rid of these sulfur emissions. They do contribute to the deaths of 8 million people a year, according to a Harvard study. In other words, the deaths due to the pollution from burning fossil fuels, not climate change, but the pollution, which includes sulfur and other things, PM 2.5, particulate matter, and things like that, cause heart disease, lung disease, all kinds of things. It's 1 in 5 deaths in the world are due to fossil fuel pollution. So it is a good thing to get rid of it from a human health point of view. However, there are these unintended consequences of accelerating global warming, which also leads to more deaths and destruction as well. Now, there's things we can do to do it more intentionally. Maybe we'll talk, there's not really a show about that, but we can talk a little bit more about how you can do that intentionally, use far less, quote, pollution to cool the earth, and then also not have the health impact that it has when you pollute near the ground where everyone breathes. So sorry for that interruption there on that, but I wanted to emphasize that there is a health reason to get rid of this stuff.
Let me show a few more graphs,
okay,
if you will. So and of course, I showed this one, and I think that's also important to mention. So there's a lot of sulfur being emitted worldwide, and that's also from not just from human anthropogenic sources, but also from natural sources like volcanoes and algae. But then you see the percentage of sulfate from shipping, and of course over the North Pacific here and the North Atlantic here, and also in different regions, you see that the majority of these emissions, especially in the Northern Hemisphere, over the oceans, is from shipping, or was from shipping. This is before the regulations came into effect, and then we talked about climate sensitivity. So you see Earth climate sensitivity, and that changes. So from these climate models, that changes the colors of these dots. So if the climate sensitivity in models is higher, then the dots are more red. And this is the long wave, so the outgoing long wave radiation. If it increases, then that means more heat is going out to space. And then this short wave, so how much sunlight is being absorbed. And then here you see the NASA Sirius satellite data. And of course, if you see that, if you have this as a dartboard, all these cloud models are very, very much off from the bullseye. Maybe this one you could study why these are maybe closer, but right, this is of course the vast majority is well outside the range of what the NASA satellites have observed. Right?
So what this upper left bullseye indicates is that we are taking in more energy into the Earth. The shortwave incoming radiation or energy heat, and it's over to the left, so it means we're the Earth is giving off less heat or energy than a lot of the models show here when they get over to the right side. So that means the Earth is going to warm more than these models say, taking in more energy, giving out less energy.
Yeah, and of course, this, from our perspective, this is a strong indication of the aerosol forcing being much stronger than the estimates are, because of course the aerosols, they reflect sunlight, they reflect more sunlight to space, and they make clouds brighter, which also reflects sunlight. So this is a strong indication that if it was greenhouse gases or water vapor feedback that caused the increase in Earth's energy imbalance, then it would be more in this direction, right? You would see the increase in long wave. There would be less heat being radiated to space, but it's we see that much more sunlight is being absorbed, and that you it's showed here as well. So this the same graph, but just the turnaround, right? So you see that, so more absorbed sunlight, increase in outgoing long wave radiation, and a decreased albedo leads to higher Earth energy imbalance. And that's, of course, also due to higher cloud feedbacks. So as the Earth warms, less clouds, and then less clouds form or clouds evaporate faster, and that also decrease how much sunlight is being reflected to space, and cause an increase in radiation of heat to space. So and I think that's also contributing now to the very rapid warming of the Mediterranean, which you also already mentioned, right? So we see that there's very little research on that. At the European Geosciences Union, there was a presentation on that, and their model stopped in 2014 because after that the models didn't have updated aerosols. So and you've talked about that with Gavin Schmidt already, where that this update has been delayed, and so we now use or many climate models now use data that's over 10 years old, and that should really be addressed. I think that's really a crying shame that this is not updated, because and in Europe even regional models, they don't take into account aerosol reductions after the 1980s even. So they keep these Cordex models, they keep the aerosol forcing, they keep it stable, so they in the models they don't reduce air pollution, and that's why you see that the warming in reality, and also especially the increased in amount how much sunlight is being is reaching the surface, increased by about 20 watts per square meter over Europe more in observations than it does in the models. You can see that here. So it's 20 watts per square meters. This is ERA 5, so the reanalysis data, and then this is the Okay, that's short wave down. So here's the cortex. You can really see that there's an enormous gap, and that's causing an increase in warming of summer warming of over 0.5 degrees Celsius.
So
if
I
you
think
don't
it's
take
important to emphasize there that what you just said. So they're using this old aerosol data. And since that time, not only have we reduced the shipping emissions, but China has greatly reduced their sulfur emissions by putting sulfur scrubbers on their coal plants, because you remember all the pictures where you couldn't literally look across the street in Beijing, because the pollution was so heavy and everyone had to walk around with a mask all day. This is before COVID, and so they decided they didn't like that. That's not good. It's very bad for health. Probably killed, over 1 million people in China every year just due to that.
and the same
So
happened in
they
Europe.
cleaned up their sulfur emissions like we did back in the 80s, where we had the problem of acid rain. So we put sulfur scrubbers on ours long ago, and now they're doing it too. And so
Eastern Europe is starting to do it more.
And Europe was doing more than anyone to switch to renewables, which was great. And Europe is the fastest warming landmass on Earth. And it, partly due to the fact that they're doing a great job in cleaning up pollution. So cleaning up pollution is a good thing, but it has these unintended consequences.
Yeah, you see it. So regionally, it's even over 1 degree warmer. In certain regions, you see that if you don't take these aerosol reduction into account, it's even 1 degree Celsius, over 1 degree Celsius warmer than when you do. So that's really enormous increase, of course. So that's
okay.
Yeah,
so we covered. So one of the big unintended. Let's see. Was this?
Oh, sorry.
No, I would listen to the cartoon. Everyone's going to want to see it. This, for those maybe listening, it's a cartoon with like an office manager looking at an employee slumped over dead with a knife in his back, and it says this person died of natural causes because people have always died of natural causes. Right. Yeah, that's the old thing, is that the climate has always changed. So that assumes that the only way the climate can change is by natural causes, but that's not true. And it's like saying, by the way, another way of putting it is there were wildfires before humans walked the earth, so humans cannot cause wildfires. Just not true.
Yeah.
So we talked about the unintended consequences of cleaning up our pollution. There are other unintended consequences of focusing solely on emissions reduction. Do you want to go into this one first before we get into, okay?
We can do it later, maybe.
Okay.
I think we've discussed this enough here. So there's it just shows that there's more warming over other regions, right? So
yeah, and you got your camera problem there. Your
know.
nice high quality camera that is freezing now and then. And you also have your new microphone, which is great as well. So a little flash down there. So I want to talk about is that there was, I'll just show it here. There was a very recent report from University of Exeter saying tipping point experts issue urgent warning. Basically, to be honest with you, it's the same warning that climate scientists have been giving for the last 20 to 40 years. Jim Hansen gave this warning in 1988 in front of Congress. And ever since then, I've been giving talks around the world on climate change for over 20 years. And it's the same warning, by the way. But this basically says that what we have to do is rapidly take steps to reduce fossil fuel emissions. And we do have to do that, by the way. But and this one actually mentions briefly that maybe we need some carbon dioxide removal as well. It doesn't mention solar radiation management at all. But anyway, so this is very typical. I mean, this is just came out, but I mean, this kind of thing is the number one call to action is to reduce our fossil fuel emissions. And people often make it sound very positive that first of all that we can do this and that we will do this. No, I'm sorry, and if we do this, that things will be okay. And unfortunately, that doesn't appear to be the case. First of all, one thing should be obvious to the folks who even wrote this warning is that this warning is like all the other warnings we've given in the past. And why is this warning going to be heeded when all the others were ignored? I mean, I think part of it is you can say that, well, now we know even more, and we're so much closer now to tipping points. We now have, 1.5 degrees of warming already. So everyone should be understanding that that's due to climate change, and therefore, things are getting dangerous. Now they're going to be ready to act. And it doesn't appear that to be the case. Look at the United States, totally backtracking on climate action, climate science of any kind, actually. I mean, and so the fact that you would think that you would hope people would act rationally in the presence of danger, but that's not always the case. People are not particularly rational as a group. I think I used to say that you can have really intelligent people, but the more people you get together, at scale, it's basically like algae eating their way to the edge of a petri dish. And someone looks up and says, "Hey, it looks like we're going to hit the edge there." And shut up and keep eating. So this situation is that there are many reasons why it's almost theoretically impossible to stay below 2 degrees Celsius of warming by reducing fossil fuel emissions only. And this is what the call to action is of this particular paper is we need to stay, it says, with global warming expected to exceed 1.5 C within a few years. The expert warned that billions of people are at risk from climate tipping points. Every fraction of a degree over 1.5 C matters, and every year of overshoot matters too. They consider overshoot to be over 1.5, and then they talk about how we must stay below 2. But it's not going to happen. I mean, this way of staying below 2, it's not really possible. Well, and for one reason is we're not reducing our emissions at all. We're at record high emissions now. In order to have even a theoretical chance of reducing our emissions enough to stay under 2, we would have to be rapidly reducing our emissions right now, not in 2 years, 3 years, but right now. And in fact, as we talked about on this program, there's a decent chance we'll be at 2C in about 10-ish years or so. We just crossed over 1.5. And so this is not rational, this approach. And the way I like to put it is, if we follow this plan, let's call it a plan, to rapidly reduce fossil fuel emissions, and that's the one thing we're going to do. That's all the energy, all the money, all the resources are going to go into that. If that is the plan, the result of that plan will be catastrophe. Because with that plan, it's almost certain, nothing is 100% certain, but it's almost certain that we're going to cross 2C. We're going to go over 2C of warming. We're going to cross tipping points beyond the ones we've already crossed, like coral reefs, the West Antarctic ice sheet. We probably have crossed that one as well. But the AMOC, we haven't crossed yet, we hope. And that one would certainly be crossed if we just continued on the path of crossing our fingers and just hoping that we reduce our emissions. I should also point out that CO2 emissions, it's not like other kinds of pollution that we're used to. We're used to, water pollution and air pollution, and maybe like in China where the air pollution was killing lots of people. We'll get rid of that pollution. We'll put on sulfur scrubbers. We'll switch to renewables. We'll do all these things. And yes, indeed, a few years later, the air is clean and people can walk around without masks on. And the same thing would be true if you lived on a river and it was polluted by a chemical plant upstream and you couldn't fish or swim anymore. And then you got your friends together, you shut down the plant, or you got them to clean up their pollution, and then you could go fishing and swimming again. That is not CO2. CO2 is a cumulative problem. We've already emitted 2.6 trillion tons. I was about to say billion because it's like the normal thing you would say. Trillion tons. And the oceans, soils, and plants absorb a little more than half of that. So there's 1.12 trillion tons of excess CO2 in the atmosphere. Roughly speaking, there's now 3 trillion tons of CO2 in the atmosphere, and pre-industrial times there was 2 trillion tons. So we've increased CO2 content of the atmosphere by 50%. Now, with that cumulative amount, the amount we're putting up there every year is, roughly speaking, 50 billion tons through fossil fuel emissions, land use changes. Maybe it's less if you only look at fossil fuels. But so getting rid of that doesn't stop the 2.6 trillion tons. All it does is decrease the increase in CO2 by about, if I remember correctly, 1.5% a year. That's the control knob we have. We remember you have this huge amount already there, and you're trying to decrease the increase by a little bit. So, in other words, we kind of really fucked up the atmosphere already. Is a simple way of putting it. And therefore, if we just only hope to fix things by decreasing fossil fuel emissions, which we do need to do, by the way, make it very clear. We do need to decrease our fossil fuel emissions. But if that's the only thing we do, we're, first of all, not doing it. Number one, if we do it, we'll do it slowly, not as the most rapid thing that could ever be imagined, which is what's required. And we're going to cross 2C, and we're going to get an AMOC collapse. We're going to get all these things that are going to fuck up everything. So a plan, let's say the plan is to reduce our fossil fuel emissions. A plan that results in catastrophe, even if you execute it, is not a good plan. That's kind of a basic point here. So your plan should include other things to, first of all, protect everyone. And by everyone, I mean not just people, but animals and plants and everything, by cooling the earth temporarily while we reduce our emissions and remove our past emissions, because we've already put way too much CO2 in the atmosphere. And Leon and Jim Hansen's research say there's more warming from the CO2 we've already put up there than we think. And there's also more cooling from the aerosols than we think. So when we finally get rid of all fossil fuels, we're going to get rid of the aerosols too. And therefore, there's going to be a lot more warming than everyone thinks. Like, again, if we turned it all off tomorrow, the human extinction scenario, that everyone goes extinct tomorrow, and therefore all fossil fuels cease immediately, the temperature in a few months would go up to over 2C. And
I think what's important to note here is that so if you reduce CO2 emissions, or indeed the instant human extinction scenario where you would stop CO2 emissions, then you would also stop fertilization, anthropogenic fertilization, and the most obvious example there is nitrogen fertilization. So the amount of nitrogen fixation over land is now 3 times as high as it was naturally, because we have added so much, of course, nitrogen fertilizer, but also with the burning of fossil fuels, there's also nitrogen being fixated, and that also deposits in ecosystems and on agricultural lands and in forests, which also increases growth and uptake of CO2. So the reduction of that's also another unintended consequence in a way. Of course, there is this nitrogen pollution problem, but in a way it also helps the ecosystem, the biosphere, to take up more CO2 from the atmosphere because there's fertilization. Together with the CO2 fertilization, there's nitrogen fertilization. And if you and I think that's also quite often either not included or underestimated, how much of that the nitrogen sink for example, that's if you see these carbon, I think that's these annual carbon balance reports. There's very little coverage on the role of nitrogen fertilization therein, right? And I think that should be more. It should get more coverage because it's crucial to take into consideration as well.
Although one thing
As,
I'll
as
say
one
on
of the
that,
many unintended consequences we are discussing now.
but one of I think exciting things happening in climate tech, where it's people working on climate solutions, is there's a lot of companies, I don't remember how many, but there are quite a few companies working on alternative nitrogen fertilization techniques that would use like microbes that would grow the nitrogen right at the plant root, for example, rather than using artificial fertilizers so basically fertilizer replacements and all different schemes for this. And they haven't scaled up yet. Fertilizer is pretty cheap, and it's what everyone's used to. So it's hard to do these things, especially when they're early stage and more expensive. But I do think that if we did get rid of artificial fertilizers, that we would find alternatives.
And many plant species already do that. So if these
right.
legumens or the soy, for example, fixates a lot of nitrogen, and that's included in this tripling of the nitrogen cycle over land, where you have a lot of agricultural plants, especially beans, that take nitrogen out of the atmosphere because there's a lot of nitrogen in the atmosphere, and they together with organisms in the soil, they fixate this nitrogen, and which again helps the plant grow better. So that's indeed that there's ways to increase that, and then that could also reduce fossil fuel use if you increased how much nitrogen is fixated by plants themselves. You don't have to burn or process fossil fuels to make these nitrates.
Right. So one of the things I mentioned earlier on is that taking the approach of emissions reduction only, which again I think is most climate activists' plan A. I mean that's what people want to just focus on. And one of the reasons they say not to do carbon removal or solar radiation management is that it might reduce the impetus, the drive to reduce our emissions by making things not so bad. And, it's only when things are bad will we react. So, and they call doing carbon removal or solar radiation management a moral hazard because it might result in reduced emissions reduction efforts. But I think you could also argue that striving for emissions reduction only and being against those other things is a moral hazard on its own, because what you're really saying is we want, not that you want, but we'll allow the global south people to suffer more because they're suffering now, and as temperatures go up they're going to even suffer more,
and ourselves,
in order to give the people in the developed countries more reason to reduce their emissions. In other words, we're not going to take climate change seriously, of course. We're not going to require the reduction of fossil fuel emissions. We're not going to actually pass policies that just require the phase out. I mean, that would be the obvious thing to do, of course, right? But no. We're going to ask the fossil fuel companies to pretty please reduce their emissions. And we need to have the climate disasters happening one after another in order to give us the political will to actually take action on climate, because we're not going to rationally look at the warnings we've gotten for 40 years, and which are all coming true, by the way. It's not like we don't have signs of this all being correct. And so the idea that we should let people in the global south suffer in order to give us more reason to reduce our emissions, to me, sounds like a moral hazard in its own right.
Yeah, and of course we've been doing that already, right? We've been already, in a way, there's quite some truth to it, because we have already been hiding the real impacts, as we just discussed. We've already been hiding the real impacts of greenhouse gas warming for centuries, and we argue in Global Warming in the Pipeline and on my recent EGU presentation, that we've been hiding the warming from greenhouse gases for thousands of years already by
Yeah.
burning all this biomass around the world, right? So in a way, we've been hiding the impacts already, and we've been kept unintentionally, again the same word, unintentionally, we've been keeping ourselves and the world ignorant of the impacts by hiding them. And so there is truth to that, right? If we would have had all these impacts for the past hundred years, let's say, I do think there would have been more action on climate. If,
Mm-hmm.
and that's even some say, let's just reduce the air pollution as fast as possible in order to have people experience how bad it will get, right? So
Oh,
and
right. Mm-hmm.
and and and, and there might be some, like, there is some truth to that, unfortunately, right?
Mm-hmm.
Because apparently people need to see how bad it gets before they act.
Right.
So, but if you look at this graph I showed you in the beginning, where you see this, how much we've changed the radiative forcing of the greenhouse gases already, that would completely change the face of our planet without the masking effect of aerosols, and let alone as we keep increasing this greenhouse gas forcing as we are doing, right? So indeed, then if you once you grasp what it really means to be faced with that, then it becomes indeed a moral hazard, because that would mean the most likely the death of billions, if you, and that's a path we are on. Some say the emissions are stabilizing, but that's only, and they blame, or they say that's because of the Paris Agreement, but I think it's mainly because of the um, COVID lockdowns and the energy wars around the world, where you see, okay, and of course that caused an increase in renewables. So, but I don't think that's some signatures in Paris, to put it a bit bluntly, um, contributed as much as these other things, right? So I don't have a lot of hope of this curve going down fast.
Right.
This greenhouse gas emissions curve going down fast.
I do agree with you, by the way, that climate impacts. I mean, to me, I've been giving talks on this for like 20 years. The only thing I've seen that got people's attention are climate impacts that are recognized as being climate impacts, but they obviously aren't serious enough yet for people to take action seriously. I mean, we talk about subsidizing renewables as the solution, but that just gives you more renewables. It doesn't give you less fossil fuels. Getting rid of, phasing out fossil fuels would actually phase out fossil fuels, but we're not willing to politically talk about that yet. And I think we will. But the other thing people have to know is that whatever temperature you have when you finally eliminate fossil fuels, putting solar radiation management aside for the moment, whatever temperature you reach when you finally eliminate all emissions of fossil fuels, that's the temperature you have for the next 1,000 years or so. And, it might be higher than that, as global warming in the pipeline paper is correct. And there's actually more warming and more cooling from these things. That might mean we have an extra 0.5 degree on top of whatever it is when we finally stop emitting. So this is really serious stuff, folks. And we're supposed to be rational creatures, but we're certainly not acting rationally here. And I understand why people want to focus on emissions reduction only. But again, that plan, if executed properly, will end in catastrophe. And that's why, by the way, I think that there's a lot of doomers out there, because they can do that calculation themselves. See, we're not reducing. See, even if we did, we're going to do it slowly. See, we're going to go way over 2 and into 3 degrees of warming, and therefore that's pretty catastrophic. But again, we
There are
do
a
have
lot of
tools in the
realists.
toolbox. Say again.
There's a lot of realists. I think that's
Realistic.
So yeah, I think that I don't like the word doomer because it's really a straw man with double N, right? It's if you see how it's used, it's often there's this picture portrayed about these people who say within 5 years, and that there's runaway warming, and we're all going to die, and
Sounds
billions
like
will
Guy
die within
McPherson
10
or
years.
something. Yeah.
And then they talk about James Hansen and calling him a doomer without saying without really saying which one he is. Well, he's just portraying the data as it is, right? He's showing the data and say this is what the data shows.
Well,
And
and I
then
think well,
compare.
I didn't mean this to be a discussion of doomers, but I do think
I
there's a
know.
difference because doomers say, and there's nothing we can do. I mean, they say, and by the way, I mean, I'll agree with doomers if we continue to do what we're doing and never act, which if we continue to choose to fail, as climate scientist Kevin Anderson would say, if we continue to choose to fail, we will. I mean, it's pretty obvious. I mean, you don't have to be, a climate scientist to know that, right? If we continue to just to continue to put fossil fuels in the atmosphere, don't take any steps to counter any of the effects, we're going to get up to 3 and 4 degrees of warming, kind of end of civilization levels of stuff here. And, we can look back when it went up 6 to 8 degrees, 252 million years ago, 90% of life on Earth perished. So it's people like to say, well, the climate's always changed. Yeah, it has. It wasn't always good, and that was something that happened over, tens of thousands, well, at least thousands or tens of thousands of years, small increases of CO2, like 100 times slower than today. And
incremental changes,
but adding up over thousands of years, and that caused the mass extinction. 90% of everything perished. So we're doing it 100 times faster, and we're just crossing our fingers that everything will be okay. So that's kind of stupid. But again, the thing about the doomers is they say there's nothing we can do when there's clearly things we could do if we chose to do them. And I don't really understand that part where they well, again, there are some doomers that don't want us to do anything. Of course, we had Elliot Jacobson on, and he just prioritizes nature over humans. And if you do that, then you kind of want humans to go away quickly to give a chance for nature to survive, the rest of nature, I should say. And that's a rational approach if that's how you prioritize things. So anyway, I didn't want to really get into the doomer side of things. I really wanted to focus on the non-doomer climate action person who really wants climate. These are climate scientists. These are, the people in the NGOs, the people at the University of Exeter. These are people that are serious about studying climate, and they know that emissions reduction is a necessary step, and it is. Then they take it a little farther, saying these other steps that might help will interfere with number one, and we need number one, so therefore don't do number 2 and number 3. And they also seem to think there's some finite budget, because if let's take a look at carbon removal. The cost of not putting up a ton of CO2 is far, far less than the cost of removing a ton of CO2 from the atmosphere, period. End of story. I mean, that is always true, always will be true. Therefore, you do any kind of economic analysis, you say, oh, whatever resources you have, put them towards reducing emissions. Don't put any, maybe do some research or something, but don't do anything serious until first you've done all of the emissions reduction you can. And that sounds logical. It does sound logical, but there's a certain fallacy in it. And the fallacy is it assumes that there's a finite budget for saving civilization. Like, there's some finite, it's never specified what it is, but whatever resources you have, which, by the way, we're putting, first of all, there's a fallacy in the whole thing because it's cheaper now to use renewable resources. So switching away from fossil fuels will save money, not cost money in the aggregate, and maybe a little more upfront right now as you get rid of assets that were supposed to be there for 40 years and you better get rid of them now. Okay. But in the long run, we're going to save literally trillions of dollars. So the whole idea that, we only have a finite amount of money, you just pass the law, which doesn't cost the government anything, that says you are not allowed to burn fossil fuels after this date in this particular application. And then you pace those things out. So that fallacy is right there. But the other fallacy is, if you do it, if you take, quote, all your resources, which isn't really a true thing, towards emissions reduction, you end with catastrophe, and therefore you failed. So that's not right, And then also, I would argue that, let's just say, and we're not doing this at all, of course, we quote, put all our available resources towards emissions reduction, and therefore there's nothing left to do carbon removal. Well, wait a second. A new cruise ship cost $1 billion. So if we're going to trade off saving civilization versus building new cruise ships or golf carts or Tupperware or whatever it might be, we have the resources to save civilization if we choose to do it. And by the way, some of these things like solar radiation management don't cost hardly anything at all, just maybe $5 billion a year, which is probably spend that on meat inspection or something. I don't know. So this premise that this is the path forward, plan A and plan A only of emissions reduction. A, we're not doing it. Two, as we do it more and more, we're going to do it way too slowly. Three, there are no situations where we can do it fast enough to stay under 2 degrees, except theoretically, which, not in any practical sense. And therefore it ends in catastrophe. So given that, if you're rational, your plan that ends in catastrophe is not a good plan. So you need to have another plan. And that plan includes reducing your emissions much more quickly than we're doing today through policy, not by small economic incentives that actually have rebound effects that you don't even know about, and therefore are not that effective. Again, subsidizing renewables is the obvious one. We've ended up so far 100% of renewables on a global net basis have gone to new energy supply and not reducing fossil fuel emissions. And the way we know this is that fossil fuel emissions are at a record high. So you kind of know that. But that didn't have to be that way. Instead of subsidizing renewables, we could have phased out fossil fuels, in which case renewables would have replaced them and grown rapidly, but it would have been a different situation. We can also do carbon removal. It's very expensive per ton right now, but we need it running at a scale that is literally 1 million times more than what we're doing today. And as you scale things up, they get cheaper. So we can spend some money now, which is, by the way, a tiny, tiny fraction of what's spent on renewable energy. It's like, just a couple $1 billion or something versus $1 trillion, $2 trillion on renewables. To do carbon removal scale up, which again, it's scaling up from a very, very tiny, tiny amount right now. People wonder, well, it's no good because it's tiny. Well, it's tiny because no one's going to pay for it. It's waste disposal. If you want a lot of it, pay for it. You can have as much as you want as long as you pay for it. Right now, it's expensive. It'll get cheaper over time. Always still more expensive than getting rid of fossil fuels, by the way. That always will be true. And then the last one is solar radiation management, which is cheap, quick, relatively quick, and would reduce pain and suffering and heat stress and crop failure and wildfires. And by the way, Arctic melt that leads to AMOC collapse and things like that quickly and effectively with some side effects. But if you're going to look at those side effects, you also have to look at the side effects of not doing it. And that's what we're talking about today. And those side effects are absolutely catastrophic any way you look at it. So that's the rant. Leon, what else do you have to add to that?
Yeah, I think you covered quite a bit already here. We could also go to questions, and maybe then
yeah. And let's see, Stacy, if you're available, you can turn your camera on, or type something in the chat here. If you're not able to, and Eli, here, okay, Stacy is here, so let's bring her on. Hey, Stacy.
Hi. How are you?
Okay.
Great to see you guys. And yeah, I am in a hotel room
in
New York.
To go on the trip.
Yes, and there was only one real question that I saw. Oh, actually, and Nadia, I see one here as well.
I mean,
but there
timestamp.
were a number of misconceptions. There are a number of misconceptions. Do you want to go with questions first?
Well, your
and
question. Yeah, you can do your question
answer
first, or
some
whatever,
questions?
or
Oh, well, mine is no. I don't have any questions. It's more just a comment of the when we're talking about this. I think the and we need to do this, and it's only going to make things worse because a lot of it started sounding like keep burning people,
Right.
and I know that there's part of it that it's like, well, yeah, that's the bargain we've struck, but I can't see my way around any is burning more. I don't know. What do you think?
your audio was not great. So repeat the question. What was the advocacy for burning more fossil fuel?
All right, let me. Oh gosh. Here, I'll try this. Better?
No, it's connection.
No, yeah, you have a weak internet.
Is that better?
You're frozen now. So you have a weak internet connection. But try it again. Try it again. What's the quick version of the question?
Okay. Comment is just more quickly saying that we must eliminate, yes, this is the bargain that we like, but the pollution kills people. The emissions are going to ultimately, we need to eliminate this. I don't even know if we should reductions anymore. It's just and it's initially presented sounds a little like we might want to consider continuing to burn.
Oh, I see. And what we're saying here? Yeah. No. Yeah. No, I think we have to make it clear that, and I said at the beginning, but probably worth saying it again, that we have to get rid of fossil fuels. And there are consequences of doing it, which can be countered, by the way, with much healthier, safer ways of doing it. I mean, just very quickly, we're doing about 70 to 100 million tons of sulfur every year. I think maybe we peaked at 100. We're down to like 70 million tons of sulfur, which contributes to the deaths of 8 million people a year. So it's pretty bad. It's also cooling the earth. We could cool the earth just as much with around 5 million tons in the stratosphere. And when it's in the stratosphere, you don't breathe it in, falls out as rain, mostly over the ocean. And therefore, as according to David Keith, who we've had on this program, it's 1,000 times safer than putting an equivalent amount of sulfur. Well, no, putting the amount of sulfur we are putting in the lower atmosphere. So yes, there's things we can do. We can reduce our emissions, avoid some of the major unintended consequences if we act with all the tools we have available, not just focusing on one. Okay.
Okay. Yeah. Just as long as it's followed up real quick.
And we do have Eli here, so I'm gonna.
We've got to end it.
And Stacy, your connection's kind of weak there, but we were able to make that out. So Eli, welcome. What's your question?
Stacy, your connection's kind of weak there.
We're getting the echo problem, Eli.
So Eli, welcome. What's your question?
Hi. So, as people are,
the echo problem with Eli.
Is it okay?
Go.
Okay. So, as people are aware, AI is arriving, and there is an insatiable demand for electricity, and therefore, people they recommissioned, or they're trying to recommission 3 Mile Island. What do you think about allying with the most retrograde elements that are pushing for coal to come back to power that using coal and emit sulfur rather than methane, fugitive methane?
Wait. So we need more power for AI and use coal versus methane to cool the Earth more?
Yes, that's right, because there are all these plants that are decommissioned or slated to be decommissioned, right? And I mean, it's a horrible thing either way, but picking your poison, I think that poison might not be the worst.
Again, I'll just say it very simply. I think since we have the choice, people are also saying put the sulfur back in ships because it'll cool the Earth. For some reason, when you do it accidentally, even though that would not be accidentally if you put it back, it would be doing it specifically to cool the Earth. That would be officially geoengineering if you did that. Taking it away isn't geoengineering, putting it back is. But since we can cool the Earth without causing all the deaths, and by the way, the long-lasting CO2 pollution that lasts for 500,000 years, some of it, it's like a false choice. That's not the choice. The choice isn't between coal and methane. You could just, by the way, through policy, require that AI use 100% renewable energy with battery storage or whatever, or wind, water, whatever. So you could do that. By the way, AI itself is dangerous, and we did a program with Will Wright, which will kill us first, AI or climate change. I think at the time, climate change came out on top. I just watched an AI episode, a video, which I'm going, maybe AI will get us first. I don't know, but in any case, it's not a requirement. First of all, it's not a requirement to do AI. We could regulate it. And there's no reason why we need to use coal or natural gas to power it. So there you go. But by the way, you got your echo problem. We got to figure out how to fix that because it's causing problems. Let's see, Stacy, do you have more?
Yeah, we questions. The one I flashed you the time. They were requesting the war's effect on climate.
1356. Wow, I don't see. Oh wait,
59.
I'm starting at 11. Oh, you're in New York. Okay, there we go.
Oh, sorry.
No, you got different timestamps than I do. Okay,
10.
I got it.
10:59.
Yeah. You got to zoom. Here we go. Getting close now.
Yeah, I think I have it already then. Yeah, so I think that of course wars. I think it's many of these wars are in part energy wars. So it's all quite complex, right? If you see the Nord Stream 2 pipeline being blown up, that's 110 billion cubic meters of gas transportation infrastructure annually being going offline, but that caused a big shock through the energy markets worldwide. That caused, for example, countries like Pakistan and Bangladesh to be unable to afford gas anymore, and they had to switch to solar power. And then you see these enormous, and then you saw the same in Europe and many other places around the world, a big boom in solar. But then you also saw this increase in LNG transports from Qatar and from the United States. So and of course, if you blow up all these air conditioning units in Gaza or wherever, this adds other greenhouse gas to the atmosphere. So there's many things. Like sometimes it's small, sometimes it's big. It's often not very straightforward. It's not just CO2 emissions from ships or from tanks, which you have to account for. It's all these enormous market shifts that are taking place. So maybe Dan has more thoughts on it, but it's
well. I mean, also you can see World War II had you can see the global temperature graph, and there's like a little up and then a down during due to the war, and that was emissions changed because economies were shutting down because of the war, but also I think there were more industrial emissions as we built up building tanks and stuff like that, and
more aerosols.
more aerosols in the air, so that ended up cooling. And then it dropped after the war, but then the re-industrial revolution happened after the war. U.S. economy grew rapidly. Emissions grew faster than, aerosols grew faster than emissions, and the temperature stabilized until the 1970s and the Clean Air Act. So we started cleaning up pollution, which cleaned up the aerosols, and then the temperature since then has been steadily rising. So yeah, I think when big wars like World War II, you can actually see the impact on the global temperature graph. So
yeah, and it's always, I think it's always very complex and difficult to see what comes out of a war, right? If you see, for example, GPS was developed to make sure that all these nuclear weapons landed on the right city, but now we use it to get ourselves to the right coffee shop, and you have nitrogen fertilizer from Haber-Bosch that was initially used to make bombs, and so I think there's always a silver lining to all the things that are developed or happen during wars, and it's almost impossible to envision what the future will bring from all that's happening now, right? Drone technology, for example, right? We don't need now drones are being developed to make sure that so to throw grenades and throw bombs, but of course there's a lot of positive uses for drones as well. And I don't know what they are all developing. I think that's many of these things are secret, but we can also hope that some of the technologies will be used for the better.
Okay. Okay, so let's see. This one, I guess, is for me. Why can't Dan understand that all forms of civilization are inherently unsustainable? Maybe true. By the way, when we take a look at why don't we see lots, there's trillions of stars, trillions of galaxies. Why don't we see signs of life, radio signals from other planets, in the universe? And one of the reasons might be that when you look at the equation of how many signals you should see, one of them is how long civilization lasts. And, maybe civilization, not just on Earth, but everywhere, is inherently unstable, that once you get the ability to send radio waves, you also have the ability to create greenhouse gases and nuclear weapons and things like that. And it's just inherently unstable. Interesting question. But right now we're faced with the question of, what do we do right now? Do we give ourselves more time to figure out maybe we should be smarter about how we run civilization? Obviously, right now, we're not very smart about how we run civilization, but we could be. And so, and Jason asked another similar question, the solar radiation management is inherently going to backfire. Well, we're already doing it. Okay, let's be clear about it. We're already using technology to cool the Earth with aerosols. We're doing it very inefficiently. We're doing it in a way that kills millions of people a year, but we are cooling the Earth quite effectively by half 1 degree. And we could do it a much more efficient, much less dangerous method that's much more controllable too, by the way. And yeah, so will it have negative side effects? Sure it will. But the negative side effects of not doing it are enormous, and like an order or magnitude or two more than the danger of doing it itself. And we know this because it happens every few times a century when there's a big volcano. It naturally cools the Earth for a year or two. And it causes problems, by the way, when that happens. There's changes in growing seasons and all this kind of stuff. But the danger I guess this is really worth emphasizing one more time. The danger we face on the path we're on is extremely high danger. And to ignore that and say, oh, but there's a little bit of risk from doing solar radiation management. When you say that, you're ignoring the risk that we're facing right now that is very clearly ahead of it. We're right. It's not even like some future thing. We're experiencing the beginning of it now, and we haven't seen anything yet to what the danger is going to be like 10, 20, 30 years from now. So that's my answer there. Then when is
So
11:04?
Nadia had one at 11:04, but she also asked one just recently, the same thing at 11:24.
Okay,
There it is.
24.
I have it.
And yeah, about sort of getting even, because 99% of humanity is wiped from the earth. The 1% that survive. This is, I've actually called for the Scarlet Sea. I'd love for there to be a record of people, whether it is individuals and their choices that they make, but more the people that head corporations and the people that are elected officials, that the policies that they make or do not make and the effect that they are having on our prospects right now. And I'd go back to 1981 or whenever Jim Hansen got
88.
in front of
Yeah.
Congress and said 88,
Yeah.
88. And
He wrote his paper in
say,
81
and
that laid it all out. He testified in Congress and said we have to reduce our fossil fuel emissions.
at
1988.
88. Okay. So, I mean, that is when there was realization. That is when people were put on notice, and in fact, people that were working on prior to that, because they have known.
Your audio, Stacy,
Yeah,
is
I think it should be
not great there, and you're freezing. But we see this question here.
okay.
So
There should
I would
be
say
a-
that, yeah, I mean, we could end up in a Mad Max kind of world, and it might be nice for the survivors to go after any of the survivors that had a role, like fossil fuel executives that had a role. That's not going to be really the thing. People are going to be focusing on surviving and not retribution. It's going to be hard to find all these people, whatever. And it's not a good situation anyway. I mean, that you're talking about after the fall, and let's try to avoid the fall in the first place, and maybe go after those people while there's still civilized society to go do things about it, rather than individuals, with spears or something like that and guns. So yeah, so I would say let's try to avoid the
Luigi.
Mad Max thing in the first place. That would be my suggestion. It's I don't know, probably a reasonable suggestion.
I would suggest that as well.
Oh, there we go. um, Okay, so here's one.
So then I don't
This
know if
one
you
I've seen a bunch of times. So we did a whole show with Ying Tao, is it? Get the name right? Who's the co-founder of MEER.org, which promotes surface reflection, literally putting mirrors on the ground, painting roofs white, and things like that. And this can have a positive impact in a local area. So you do that in a city that's like black asphalt everywhere. You paint the roofs right, you put trees up and everything. It can actually make a very noticeable change in the warmth in that particular location, but it won't make a change in the global surface temperature. To do that, to do the same, just to cancel out current global warming of around 1.5 degrees, you'd have to put up mirrors literally the size of the entire United States, which, by the way, is only 1.8% of the surface area of the globe, which is kind of mind-blowing when you think about it, that the entire United States with Alaska and Hawaii thrown in is about 1.8% of the surface area of the globe. And that's about how many mirrors you need to counter the global warming we have. That ain't going to happen. So again, totally great to deploy surface reflection. We should use it, especially for urban centers with high populations suffering from heat, that will have a noticeable real impact in those areas and reduce the need for air conditioning and all that kind of stuff. So it's a good thing to do. It's not a global solution. It's a local solution. Okay, but what else did you have?
there? Yeah, that a good policy would be that one white, 1/3 have solar upon them, and one are greened. That it, that is a winning combinations, and that we're not making it work for us kind of silly.
Let's see. As Nadia says here, there's more things breaking down than just the climate. I agree. We're crossing many planetary boundaries. Nitrogen, actually phosphorus, plastic pollution. There's the whole overconsumption in general of things. And, we had William Rees on a while ago for a very happy talk there. And so, yes, I agree. But I also think that climate is going to get us probably first. These other things are really bad, and they're having impacts now. But if we don't take care of climate, we won't be around to address the other ones anyway. So I do think it's worth focusing on climate as sort of a primary, even though you could say climate change is an offshoot of overconsumption. It's the pollution component of overconsumption. I wouldn't disagree with that, but we can still focus on it and look at solutions to the climate issue. Okay. Any others, Stacy, or before we go? We've been going for an hour and a half, so there's no reason to keep going.
Just the things I would to have cleared up are that whether water vapor or CO2 has a bigger impact on the environment.
So, okay, that's a good question, and the answer, and then Leon can jump in on this. CO2 is a forcing. It is something we emit into the atmosphere. We take it from underground, where it's been sitting there for 100 million years. We dig it up. The biggest industry on Earth is designed to take sequestered CO2 from underground and put it in the atmosphere. That's what our civilization system does. So that the CO2 we put in the atmosphere forces the climate to change. One of the things it does is increase the global temperature. Higher global temperatures allow more water vapor to stay in the atmosphere, because the water vapor varies, minute to minute, hour by hour, depending on local conditions. And one of them is the temperature. So by increasing the global average temperature, we increase water vapor. So it is a feedback. It's a feedback. And so it's not really worth saying which is stronger. I mean, CO2 is doing the warming. It then adds CO2 is doing the warming. It then adds water vapor, which increases the warming. It's still the CO2 that forced the water vapor feedback, and therefore that warming. So it's really, so the answer to the question is CO2 is the control knob, not water vapor. Water vapor amplifies the CO2 effect.
Yeah, and then the risk, of course, comes also from the water vapor, especially as you see now in Texas, when this water vapor cools down and condensates against aerosols, and then it forms rain, and then it all comes down at once. It can take away all these houses, these children, and it can kill people, right? So water vapor it has, of course, can have a lot of impacts. I think it's quite it will be quite scary to see what happens over the Mediterranean, as it's now extremely hot. Places now 7 degrees Celsius above average. Once it starts raining, once it cools down, then that can come down, as we've seen in recent years. Well, I think it was 2023 when 30% of agricultural land of Greece was lost. We had all these extreme rain events, and we had so many that you almost forget the ones we had a few years ago. And now we are breaking new records again in the Mediterranean, right? And really this extreme acceleration of warming over the northern hemisphere mid latitudes will bring a lot of water vapor into the atmosphere, and once it cools down, it will come down, and that's a big risk.
Okay. By the way, let's end on this. It's a programming note. Nadia was wondering about Clubhouse. So we used to, when we did our YouTube videos, we would do them via Zoom, and we would, you could find the Zoom link on Clubhouse. But now we've phased out Clubhouse. And I just realized it might automatically be generating rooms every week. I'm not sure. But we're no longer using Zoom. We're using what's called Restream. And Restream doesn't allow a lot of people on it like Zoom did. So we're not inviting sort of audience members onto the Restream, and we're getting the questions via YouTube live comments. So that's what we're doing now, and that's why Clubhouse is basically, we're not streaming to Clubhouse anymore. We did do it both when we had the Zoom, but the Restream doesn't allow that. So anyway, that's a little programming note. And speaking of programming notes, let me repeat our upcoming guests. Next Sunday, Sanjay Waggle, who's an investor in climate adaptation, something you really don't hear much about, even in clean tech circles. It's not something that's a thing. And so we're going to learn about that and what that all means. Thursday, July 17th, and let me tell you the time, 3 p.m. Pacific time. 3 p.m. Pacific time, we have Matthew England, who has a kind of like big deal paper that says the rapid acceleration and warming is due to ocean stratification. So it could be kind of replacing Leon and Jim Hansen's theory a little bit, but actually I think it's probably more complementary to them than it is.
And you're on the Atlantic, right? North Atlantic.
In the North Atlantic, yeah, in the North Atlantic. And basically, if I got it right, basically rather than having this much ocean, the ocean is stratified so that it's this much. Therefore, it's easier to warm it up with sunlight, and therefore the temperature has gone up. I mean, it's probably a way oversimplification, but we'll learn more about that. He's also done lots of work on AMOC and the southern, the Antarctic ocean currents and things like that. So it'll be really fascinating. That's Thursday at 3 p.m., July 17th. Sunday, July 20th, Ben Santer, super well-known climate scientist, semi-retired now, did some of the pioneering work on how we know that climate change is caused by humans. So it'll be really interesting. And then on Thursday, July 31st at 10 a.m. Pacific, our sort of normal time, but different day, Stephen Chu, Nobel laureate, U.S. Department of Energy Secretary under Obama, now a professor at Stanford, well-versed in climate change. I met him originally because I saw him give a talk on climate change. This is, back when he was the head of the Lawrence Berkeley Laboratories. And so fantastic, super smart guy, as you might imagine. And we'll have a chance not only to ask him about climate change, climate science kinds of things, but the politics behind why we didn't really act on climate, because he was there in the government and could see all of that. So that'll be fascinating as well. And then plus future guests. And so please keep the suggestions for future guests. You can put it in the comments here or on the recorded YouTube channel comments, or climatechatclub@gmail.com. The club part is left over from the Clubhouse days. And so we're always open to suggestions and from people, and we've taken advantage of some of those as well. So I want to thank Leon, Stacy, Eli, and everyone listening to this. Remember, please like and subscribe. We don't push it very much like other channels do, but it is important because we're trying to get the word out on our climate situation. The more you like and subscribe, the more people that will see it. And it's free, and it's an easy thing to do to help promote climate information. So thank you for that, and we will see you next time. Thanks, everyone, for coming. Take care. Bye-bye.
Thank you, Dan. Bye.